So what I was saying was that I'm gonna um, have the programming questions for midterm done before the break, study break, and immediately after study break, we'll do the concept. So you have time to go through all your readings and stuff, so you can do it. And then for the program, and the programming one is the one that takes days to mark. So that's that I'm going to do, and you're going to have more time to do it. So I'll give you an hour and a half, the whole 2 periods, to go through your programming. But I'm not going to make it bigger. It's the size going to be, you just have more time to do it. So hopefully I get better results. And then the concept questions are going to be after like that first lab you have after the break. That's when you got to do your concept questions. Something like 30 minutes to go through some multiple choices and walkthroughs and things like that. And that's that. Okay? Quiz. Probably we're not going to do another one before the break, and you're going to do 3 after the break. So every other week, you're going to do 1 quiz. Or I'll tell you, I'll announce you a week before. So those are going to be the quizzes. Next week, today, it's going to be online. Okay, I'm not going to be at school. The lab is going to be a lecture, and it's going to be online. Keep that in mind. Don't come all the way over here. I'll send the announcement, of course, but just letting you know. So did I talk about range-based loops in this class? I did, right? Okay. Yeah, range-based for loop, yeah. And we, so let me just quickly go through what we talked about. We don't need that. So we converted, don't need that one either. We talked about association, aggregation, and composition. We said that association is essentially when 2 classes live independently, but they have relationship with each other. Aggregation was when one class takes, creates and destroys the other the instances of the other class, but still they can exist separately. And we said composition is the strongest of all, which one class is fully dependent to the other class. It cannot exist on its own, and the other class takes care of all its existence. And the house and the room was a perfect example for that. Then we talked about templates, and I explained how to convert a class to a template. After a while, when you get used to templates, then you don't need to write a class and then convert. Okay? But initially, when you're starting, because we are coming from 244 and we're not used to it, when you want to create a template, first create a class with a regular type and then convert it. But if you're comfortable, you can just start off writing a template from scratch. As we said, templates always, each template tag only affects the scope after. It doesn't matter if it's a block scope or it's just a statement. It only affects that one. And if you have code that is outside of the class, they must have the tag of their own. The type names don't have to be the same. It doesn't matter. Yes? Better? Okay, is it good? All right, you want me to push this over? Okay, so, all right. Yeah, so, what was I saying? Yeah, so it does, the type name doesn't have to be exactly the same. You can have any type name that you want, and you can pass, but you have to make sure you have the template for each scope as you're going through it. Next thing was to make sure when you are converting something to a template, understand that every single class name that you have must carry the signature of the template, like line 21, as you see over here, with 3 exceptions. Number 1 is the class name that comes right after the template. Number 2 is the names of all the constructors. and number 3 is the name of the destructor. These are the ones that they don't get the tag. Other than that, you have to add the tag to every and each. Why? Because a class does not carry a signature, and for the compiler to know how to generate it, you need to give it the signature so it knows, for example, when it's creating this constructor, which class this constructor belongs to. That's why you have to carry the signature for all the class names. Obviously, this is not going to carry it because it's the constructor name, but the owner, it needs to know which one it belongs to. Then we talked about, I gave you an example, and I showed you how the new function signatures are. And we will see soon that if these are absolutely necessary when we are coming in future to functions that their return type are decided at compile time. Because of that fact, it has to be afterwards so it knows what it's actually generating, and also for lambda expressions that we're going to see what they are today. So this is the new syntax for functions in C++, but there's no problem with it. I mean, like, it's really not a big deal. The only thing is that you just put the return type afterwards and you say auto at the beginning. Otherwise, it's the same thing. Everything else remains exactly the same. We created an integer function over there, getInt function foolproof one, and we said when we are creating a foolproof function for this getInt, not to only be getInt, either I have to inject the validation for the type of the integer I want to get inside the code and recompile every time, or I have to write individual functions with different names like get adult age. Somebody's logging in from here? You can actually do that. If you don't see the screen, you can put it in front of you. Anyways. So yeah, either we have to inject or I have to write like a get adult age, and in get adult age call the thing, which means I have to write a new function, full function for integer entry every time. We didn't want that. That's when we realized that exactly like arrays, when you are exactly like arrays, when you create a function as an array carries the address of series of array elements that you have in the memory, a function holds the address of the code in the memory. So essentially, each function that you write, the name of the function is literally the address of where the code of that function begins in memory. Sorry, I'm looking at my real estate over here. So, yeah. So an interesting question came up in the other class as the address of the functions and how the functions are actually called. And I had to actually explain through a stack, but I don't have a visible thing to record over here, so I don't know what to do. Anybody have a webcam by any chance? No? Anyways, next class that I'm online, you tell me, and I'm going to draw it on the. I don't even have my pen. Let me just see if I can actually, because I want to see how good it's going to draw over here. So if I go, not bad, right? So probably when the time comes, let's see. No, it has to be. I'll see if I can do something. We'll see. Anyways. So, yeah. So when we came through function calls, and I explained what. Remember, I showed you a stack, and I said the stack is first in and last out type of a And we said if we didn't have a stack, function calls wouldn't be possible. So I gave an explanation on it and explained exactly why. Okay? So I'll find a way to do it. Probably in the break. So probably I'm going to use my cell phone to connect the big blue button and put it over there and film it like that or something. We'll find out. Anyway, so we'll come to it. So we found out that the name of the functions hold the address of the beginning of the code in the memory. Therefore, if somehow I can create a pointer that can hold the address of a function, I can use that pointer to call different functions. And we said if we just create a prototype with the exact same signature of the functions we have, that they share the same signature, all we need to do is to put the name of that prototype in parentheses with an asterisk, and that becomes a pointer. It's not a function prototype anymore. Therefore, FPTR over here is a function pointer that can hold the address of any logic that accepts 2 integers as arguments and return nothing. So anything with that will work, right? And then we set that one to the names of the 3 functions we had over there, and the execution was done. So we understood we can actually execute. When I say FPTR 40 and 10, and I have sum, then sum is called. When I say 40 and 10, the product is called, repeat is called. And not only that, I can actually create an array of 3 function pointers and set them to different things and put it in loops. Because it goes into a loop, every single element will call a new function. So FP0 is sum, FP1 is prod, and FP2 is repeat. Therefore, in this loop, 3 different functions are called. This looks fancy and nice, but how we can actually apply that to make our life easier? We said that this gives us a huge advantage, which I did not actually cover. So I'm going to tell you what that huge advantage is today. Are we okay down to this point? So yes. Huh? What'd you say? One more time. So I have a variable called FPTR. It's a single variable. And I'm setting it to 3. So every time I'm setting it, it overrides the old one. Right. Then I create 3 variables over here. Okay, so it's separate enough. Yeah, it's called FP. That's FP. It's FP. 2 different names. Potatoes. This one is tomatoes. Okay. 2 different things. Okay. Apples, oranges. All right. Okay. All right. So let me get my cheat sheet over here so I don't have to type the whole damn thing. Yes. Okay. So now let's go back to that get int now. So we have, where's the get int? Shoot, I closed it. Let me get it from here. So this is the get int we had. Right? This is the get int. And I had couple of functions over here. Is adult and valid number of students, right? Now, both these functions receive an integer and return a Boolean, right? That's all they are. So what if I come to this get in thingy, and in here I'm going to say and I make that a pointer to a function that accepts an int and returns a Boolean. So the signature of this function is identical to that. We want me to convert that back to regular functions if it's confusing? Yes? yes. Okay. Okay, okay, Bull. The most desperate yes I've ever seen in my life. Yes. Okay. 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 So now this is a pointer to a function, right? And what I can do, I'm going to go up and make the signature over here of this one correct too. And I'm going to by default set it to null PTR, which means they can provide it or not provide it. It's an address, right? Then in here, I'm going to come to that is adult, and in here, I'm just going to say is valid. And in here, I'm going to say, I'm not going to print any message. Okay? Instead, I'm going to say, hey, when you are doing your validation, print a message for me. So I'm going to write in the description, when you are doing a validation, if it's not valid, print a message for me. So they're going to write is adult over here. They're going to write over here if in here I'm going to say, so is adult was true, right? So I'm going to say not or shoot, Boolean ret or okay. So I'm going to say Boolean okay is that. Then I'm going to say if not okay. Now what do I do? In here I'm going to say only no children. No children. Or seniors, please. Something like that, and I'm going to return OK. Right? And I'm going to do the same thing over here. So if not OK, invalid number of students. Okay? So that's what I have over there. So if it's true otherwise, else, I'm going to just print a prompt for them to get it. So if it's valid, it's going to be true. Otherwise, I'm going to show that. All right? So now, as you see, my getInt requires some kind of a thing. If I don't want anything, what do I need to do? In here, I have to say, what is the condition to be true? Either is valid must be null, or it should return something, right? So in here, I'm going to say if is valid is equal to null PTR, or is valid as that, done is true. Which means if they don't want validation, I'm good, as long as the integer is valid. And this is lazy evaluation. Remember that? Everybody knows what lazy evaluation is? You don't know what lazy evaluation is? Okay, so this is a lamp. This is a battery. This is a switch. No, not that. That's not a switch. Let me make another switch. This is a switch. I'm sorry for my lack of artistic values in here. Okay, so that's a circuit. So the electricity, oh my God, that looks ugly, but it works, eh? So the electricity must pass through for the light to go on, correct? Now, if one of the switches are closed, the light will go on. Do I need to check for the second one? No, that's called lazy evaluation. So for OR, this is an OR statement. For OR statement, if one of them is closed, I don't need to check the other one. So if the first one, and that's exactly what the compiler does. If the first one is true, it's not going to even execute the second one. Therefore, nothing happens. Therefore, you're not going to get a null pointer assignment and crash, because no evaluation happens. The function is not called. We're good. Are we OK with this? And lazy evaluation for AND is this. Which essentially means if one of them is off, the light is off. You don't need to check the second one. So lazy evaluation for AND is falsehood. Lazy evaluation for OR is truth. Are we OK? Having said all that, let's go back and see what happens. So in here, if I want to get someone's age, I'm going to say cout age. So in here, I don't need to go to new line to have to work in the same way. And in here, I need to go to new line to make everything unified. So in here, I'm going to say age. And then I'm going to say over here, int age is set to get int. And I'm going to say over here is adult. Done. Because now the logic of is adult will be passed to is valid. When is valid is called, is adult is called. So we don't have to write code again. You just say, this is my function. If you want to use my function, either don't pass anything to it, or if you want to pass something, that's the specification of a validation function. It should receive this and that, and it should print a message without going to new line, and yada, 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 whatever. OK? And that's that. So and now if I'm going to say cout, you are whatever years old. Forget it. Please write it yourself. Or I can say over here int number of students, and then it's going to be get int valid number of students. That's the one. So that's going to be valid number student, and in here is going to be just an int will be equal to get int. Please run it at home and walk through it and see what happens. Are we OK with this? I'm going to walk through it, but I'm not going to print anything. So for the first one, when it actually comes through here, I have build errors. Nice. Must return a value. Line 15. Oh, yeah. Oh, stupid compiler. OK. Return. All right. So when it comes to here, obviously, if I enter over here, what did I do? Where is age? And in here it's going to be cout number of students. That's better. So now age over here, if I put over here 200, it's going to say no children or seniors, please, okay? And it's going to keep asking. If I put bad thing, now invalid integer is going to kick in. And if I put over here 40, now it's going to accept and go to next one. And the other one, when I run it over here, if I put over here 50, invalid number of students. So as you see, the proper function is called. And I put garbage, it's garbage. And if I put 30, it passes through. And for the other one, no validation is done. It's just validation for an integer. Any integer you put over there, it will accept. Are we okay with this? This has nothing to do with C++. This is pure C. You could have done this in C. This has nothing to do with C++. Okay? Are we okay? All right. So A, pointer to funcs in use.cpp. We save that. It has nothing to do with polymorphism. It's exactly opposite of polymorphism because it must exactly carry the same signature. Right? If they don't, it won't. Yeah. It's literally, this is extremely low level, people. Please appreciate that. It's as if you're writing assembly code. You're literally passing the address of logic and tell to the compiler, go to that logic. Tell to the CPU, go to that logic and execute it. Okay? So then you have to write a new function called getAdultAge. No, because it's not in the belly of the. In here, I'm calling it general function with that signature. Any signature can be passed to it. It should be a SIN number. It could be a SIN number. It could be a student number. It could be an age.
So once the program catches that signature, send it?
We can send it as an argument to the function. So getInt uses that logic to do it. You don't have to write user. You don't have to do a loop in it. You don't have to keep asking the user if it's invalid to repeat something. You just do one validation, and this function will take care of it for you. You reuse your code much more efficiently. Instead of having 5 different functions for integer entries, you have one integer function with multiple validations, which makes more sense. Are we good? You're not satisfied. What? This is a lot more work? If I did not have this one, I had to do this. First of all, every single function you have to write. Pardon me? Because? Okay. What? But wait. You used it only for one thing. Now I want to have a getInt that receives the number of people in Canada. Then I want to have another one that receives the age of a child in kindergarten. Then I, okay, all right. As long, okay, all right. Okay, good. Whew. All right. Now that we are there, let's see what object orientation is doing to accomplish the same thing. Okay? I'm going to keep the get int over here. Please appreciate the fact that parentheses in front of a pointer is a function call. It's just an operator. As square brackets in front of a pointer means index for an array, just like an operator. We could overload that to do whatever we want with that index. Remember that? So if you want validation, why not say, let's say I want to have let me first give you the syntax. Let's say I want to add two things together, okay, in many different ways. And I want to pass these things to different functions, okay? So I want to add two doubles, add to this, add to, and I want to pass these things. For that, I have to create several different pointer to functions and pass them, right? And it's not going to work the same way, because if the signature changes, I'm in trouble. What if I could encapsulate all these actions in a class? Let's take a look. Say I have a class called adding. So this class's job will be to add things. I'm just going to do with one first, and then we're going to keep going. So in here, I'm going to say public, and I'm going to say int operator function call, int n1, int n2. And in here, I'm going to say return n1 plus n2. Okay? The simplest, come on, you can do it. There we go. All right. So I just overloaded something in it. Just if it was less than operator, we would know what it is. This is an operator for function call. So how do I actually use this thing? If I say over here, adding, add becomes an object of type adding, correct? Now in here, if I say integer a and b set to 20, let's say, I can say a is equal to add operator overload, right? In here, I'm going to put b and 30. Right? So the object, I put the operator in front of it, and the operator is going to get called, right? So essentially, and I'm going to say over here, see out a. So sorry, I want to put that one over there, so we're going to use it in future. So if I run this now, so if I run this now, what can I do? It comes right in here, gets those, and as soon as it comes here, it goes to that one and does the adding and returns it, and a becomes 30 as 50 as what we see. Are we okay with this? Any problem with this? Okay. Now I can overload this for whatever I want. I can say over here for double, and this one's going to be double, double. I can have employee, I can have vectors, I can have anything I want. I'm not going to bother. And the good thing is that because it's a class, I can do extra stuff. Like how many times addition happened? You can't do that with a regular function. In here, I'm going to say, I don't know, size t, number of operations. right? And then in here, I'm going to say number of operations plus plus, number of operations plus plus. And then in here, I'm going to say, size t, number of operations. I'm a bad person. Const, I'm going to fix that. Return m number of operations. Okay, so now in here I can actually say, like, if I actually do this, cout add dot number of operations times. And you can actually take control of stuff like this. Oh, and then fix your errors. What's the error? Stupid compiler. Okay, so one more time. There you go. So we'll say add it 5 times. So this is beautiful. I have much more control. It's not only functionality. So how can we actually apply this to what we want? Let me copy this for the next. Oh, no, not that. By the way, these guys, any class that the function call operator is overloaded in it is called a functor. It's function. They call it function object. Functors. Yeah. That's a fancy name that they put for it. But let's see how we're going to actually. So there's nothing special. It's just a class that you overloaded something. But let's see how we can actually use this. Now what I can do is this. Instead of writing a get int like that, did I save this? No, I didn't. This was b functors intro. So what I'm going to do in here would be this. One of the ways of doing this would be this. I create a class called int validation. And I have the number of operations or whatever I have in there if I want to have. And let's add that one over here, number of validations. In here, I'm going to say int number of validations. And return m number of validations, make it a constant. Okay? So I can create something. It says to do int validation, you need to have the operator yada yada and have a string set to your error message. So that's because now I have a class, I can actually do whatever I want to do with it, right? So now, if I want to have a valid age thingy created, I'm going to create a class, call it valid age. And in here, I'm going to say public int validation. Okay? And in here, I am going to implement the validation as follows. I'm going to say if val is less than 18 or val is greater than 65, I'm going to say error message is equal to no children or seniors. Okay? Like that. And OK is equal to OK, and I'm going to say OK is equal to like that, and return OK. Are we OK? All right. So now I have this set up for myself. What I can do in here, all I need to do is to write my code like this. If valid num, and I'm going to have a message that is blank. So if this thing is true, that's not going to set and it comes out. It calls the validation, right? And if it's not, then it comes out like that. It shows the message and goes back up. So now you can pass your functions around inside objects. That's object-oriented way. The exact same thing is accomplished using functors. You okay? All right? Coffee? Anyone? I see everybody's falling asleep. So that's essentially functors. Okay, so functors in use. Yes. Pardon me? 43? Oh, that's a new version of validation. There we go. Especially for you, my friend. Okay? All right. So questions were asked. What if I have a template? Can I have a pointer to a function for a template? Okay? The answer is of course. What's the difference? There's absolutely no difference between a template. So if I have a Boolean ascending, Boolean descending, two templates, and I have a function template for a sort that accepts a pointer to a function that receives two types. And I have a display that displays all the stuff. Now if I want to call it, what do? I'm going to say sort A7 with ascending int. By doing this, you're requesting the compiler to generate the function for you and return its address. Again, remember, everything applies. Like a function template has it's no difference with the regular template, regular function. They're both functions. One is created by the compiler, one is created by you. And it works the exact same. So and if I want to write the exact same thing using functors, then I'm going to create an enumeration of order ascending and descending. So it tells me which one I'm going to use. Then I'm going to create a class called compare, which is supposed to be written comparison. I did compare. Anyways. And I have the order with this thing that I want. Then now I can actually create a constructor and say the comparison is supposed to happen ascending or descending. So it sets it that way. Now my operator between the two integers, depending on its being ascending or descending, returns the proper value. Right? Now, I simply pass a constant compare reference comp and use the exact same thing. So using functors, using function pointers, they all work the same way. Digested? One person did. The rest are asleep. Are we okay? Are we okay with this? So again, I have an enumeration to identify if I'm ascending or descending. I have a class called a functor, a function object called compare that decides in which order. The constructor of that comparison sets it to either ascending or descending and does the comparison between the two using the function call operator between the two, depending on it being ascending or descending, ascending greater than or less than. Therefore, I can pass the comparison to the sort and use the exact same function call to set it to ascending or descending. Therefore, in my main, this is how I do. So I'm creating sort A and yada yada, create a temporary nameless object of type compare, ascending, send it to it. This one is compare, descending, and it makes it so readable. Like when you look at this thing, you know I'm sorting the array n up to this size, and I am comparing the values to be ascending. It's very nice, actually. It's very readable. And the other ones is not. When you make it object-oriented, it looks more complex, but as soon as you get used to the syntax, it becomes more readable. And now, fun begins. Yes, we can. That's exactly what I wanted to say, actually. Fun begins after these messages. Okay, so let's go for a break. We'll come back after 10 minutes, and we're going to talk about temporary functions, if that makes sense at all. Please remind me to resume recording. Let's say I want to that get in thingy that we had with the pointer to function. Let me bring it up. So where is it? Pointer and function. So this is the one, right? Yeah. So this is the get int we had. So I'm supposed to check for a, say, some integer that is easy to validate. What do we do? Positive number. Let's say I want only positive numbers to be added to something. I don't want to write a function for it. Just so I'm going to say over here, cout, enter a positive value. Yeah, whatever. Oh, why am I looking there? I'm like, what? It says here. Okay, so now in here I'm going to say int num is equal to get int. I'm just going to write the function right here. So I'm going to do this, right? Then I'm going to pass an integer to it, right? So I'm going to say integer number or value. Then in here, I'm going to say return a Boolean after. And write the function right here. Let me see. Yeah, so in here I'm going to say, what do I write? I'm going to say over here, what do we write? I'm going to write the same thing. Boolean, OK, and is equal to false. And in here, or I'm going to say Boolean is set to, I set positive number, right? So val being greater than 0, right? Or equal to 0. And I'm going to say if not OK, I'm going to say cout only positive values. Or I don't do that, just, I think if I do just like this, that was the case. And then in here, I'm going to say return OK. And why am I getting an error over here? Oh, capital I. And return would be nice. Done. Because the function was small, I didn't want to write the function. So what I wrote is called a lambda expression. Lambda expressions are literally named as functions. So I'm saying it's a function. I put square brackets. Weird. Then I put parentheses for what the function is going to be. And I write the function. And this is where you need that bool thingy, because you cannot put it behind it. It has to put after. OK? So you say it returns a Boolean, and you write exactly what you want in a function. Done. So you don't have to. And because I just wanted to write this once, I wrote it here. I didn't write it outside. That's what lambda expressions are. When you want to write short little functions right off the bat, of course, I could have done this. So let me just C, D, E, F, lambda example. I could have done this. Auto is positive is equal to I could have done this. By writing auto, I know that it's going to take the whatever the type is, right? Equals to, then I write the lambda in front of it. But that kind of defies the purpose for me. Because if I wanted to, unless you really want this thing to just be here and nowhere else, so this lambda, it's inside the scope of main now. And it's not visible anywhere. Just want to write a little short thing to write. You could do this too. There's valid thing. But writing it as a global variable out there, that's stupid, I think. Just write a regular function for heaven's sake. Why lambda? Okay, so lambdas are for these reasons. And they come very handy in doing processes like this. So what is the syntax for it? I am recording, right? Yes, I'm recording. Okay. I have my cheat sheet. I'm trying to find the thing from cheat sheet. So that's, we don't need that anymore. Just a second. So this is lambda syntax. So in the first, the square brackets that you have what we call capture clause. What is a capture clause? Because lambdas are functions written inside a scope, we need to know what happens to the variables outside of the scope. How does the lambda access those things? For example, in here I'm saying, what if I had a bool OK over here? What would happen? Because this is inside that scope, right? Can I have a bool over here and not have OK over here and use that one? Can the lambda access the neighboring variables at all? Yes, it can. You can set it. That's what we call capture clause. So in the capture clause, we can actually write how we want a lambda to access things around. Okay? So we can actually say that's the parameter list, and that's the return type and the body of the lambda. That's that. We know that. I've already shown it to you. If you don't put anything over there, it means two separate things. What's inside lambda is inside lambda. And if you have the same variable name or not variable name, nothing outside is accessible. Two separate scopes. If you write equal, that means I want to capture all the values in the neighboring variables by value, all the variables by value, which means anything you have outside you can use inside, but if you change their values, the values outside won't change. It's by value. Okay? If you have the same name of variable inside and outside, like any other scope, it shadows the outside variables, like anything that you have. So remember, all the previous rules of scopes and shadowing variables and everything apply. If you put ampersand, it means I want to use everything that is out there by reference, which means you access all the neighboring values, and if you change the values, the value outside will change. Or you can specifically mention, I want x to be by value and y to be by reference. You can do that. So depending on what you want, and everything else is not accessible. Okay? Or you can put an assignment operator, comma, ampersand y. It means everything by value, y by reference. And you can add as many you want. So exactly how you want to access things outside, you just list it over here. Okay? Are we good? Yeah. So that's that. Yeah. Okay. Same thing. All. Yeah, the same thing. Yeah, same thing. Exactly. Yes, you're absolutely right. That's an object, right? You can access it by reference, by value, however you want. And I'm going to write a code over here for you that we're going to teach in the next few weeks. Just want you to see what is it going to look like in future, how we're going to write C++ code. I want to have an array of things. You don't use arrays anymore. There is a standard template library that is much more efficient than an array called a vector. You now know what templates are. We created the dynamic array. You say, I want a vector of type integers with these values in it. As simple as that. Then you say, sort from the vector's beginning to the end. You pass a lambda to compare the two. Right? Then you say, start from the beginning, go to the end, show all the values, and get out. So what is sort? Sort is an algorithm that is within the standard template library and standard library of algorithm library of C. You not only, it is in algorithm header file. You not only can sort, but you can also say, I want it to be sorted in parallel, which means I want you to do the sorting process in divide the things that you are sorting in 5 and sort 5 things and do things faster for me. We'll come to parallel processing. I'll explain to you how it's done. So all the programs you're writing starts from A goes to B, right? It's linear. It's not like that anymore. When you write a program, if you have massive amount of data, you divide the data to the number of CPUs you have on your computer. And then you write one function and you say, now this function should run, each one of them should run on a separate chunk in 10 CPUs on my computer. Poof, and it runs 10 times faster almost. Okay? It runs 9 times faster because of the, but anyways. So all these things we'll see. But again, this is how, why we are teaching all these. Because people say, well, why? Like we were like living happily with all the things we had. When you learn all these things, your programming time shortens by a factor of 10. And your efficiency increases by a factor of 100. Because no matter how well you write your sort, it's never going to be like the sort that is implemented by people who wrote C++. You follow what I'm saying? So she says, oh, well, I write. But no, yeah, but anyways. So that's, I call look into future. And an example of lambda expressions. Again, please run this at home. One by one, go through it. I kind of gave example of everything that is you're supposed to do. So I wrote 3 different lambdas. One of them is getting by reference. One of them is not getting anything. This one is getting by reference. And you keep going forward. I have things like you go through it, everything like this one is receiving A by value, I by reference. So all the things that we talked about, I put it over here and showed you how everything is done. So please go through this. It's just a silly example of lambda expressions, simple things to go through. Oh, I have 2 H's. So I am standing over here at this side, and I want to play a game, which is essentially, I'm going to throw different type of balls from here, and I'm going to ask you guys to catch it. So I'm going to say the first throw is going to catch any type of ball that I'm sending. The second one is going to catch soccer balls. Third one is going to catch basketballs, and the last throws are going to catch volleyball. Okay? Now, if I throw a soccer ball, who's going to catch it? No, the first throw. Ha-ha! Because I said any type of ball, right? I ordered you incorrectly. I put the general thing at the beginning. So if I throw a ball and the general thing, like any type of ball in front, So I have to reset it. I have to say volleyball, basketball, soccer ball, ball, and at the end, anything I throw. So if I throw a chair, last row is going to grab it. Okay? If I throw, I don't know, basketball, the second row. So each one is going to take it. And that's how it works. You understand this game? This game is called exception handling in programming. Some companies like it, some companies don't like it. I mean, when I show you an example, you'll see an exception should be handled exactly as what it means, as an exception, not a logic in your program. When an exception happens, it defies all the logic of your application and gets the execution of your application to some other place. All the for loops, classes, everything that you do gets stopped and something else is going to get executed. When do you do this? When some catastrophic matter is happening. You shouldn't do it for like, I'm going to give you an example for exception handling for validating an integer. That's stupid. I'm just showing you the syntax. And exception handling should not happen if you cannot open a file. If you cannot open a file, you should say the file doesn't exist. Check it to see if it's not or not. But if you try to open a file and the device fails, and you'll see that the hard drive failed, then that's an exception. If you are allocating memory and the memory is not there, we have two choices. Either you check to see if it's null or not, or you actually include the, I think it's called new header file. It's literally called NEW, if I recall correctly. When you include that, then when memory is not enough, it's not going to return null anymore. It actually throws an exception. So you can deal with it like if I don't have enough memory, it's a critical matter. I need to stop everything and shut down the program and take care of the things before it hits the fan, right? So that's what exception handling is. And what is the exception handling syntax? You always try to throw an exception, and then you catch it. You try to throw an exception, and you catch it. The exceptions that are not tried will be caught by operating system, which means you've done it, right? You go out of the boundary of the array, and it stops the whole application. You can actually cache those exceptions. So if you pass through the size of the array, you can cache the exception and show a message, something like that. But anyways, so this is the syntax for it. I'm just going to show a syntax. And this is just for syntax matter. This is just like the most stupid program you can write. So I'm writing a loop, and I'm going through this loop 3 times. Inside the loop, I wrote a complete structure of exception handling. A try block in which you throw stuff, a try block in which you throw stuff, and series of catches after trying. Anything that is thrown inside the try statement will be caught by the catch phrases back to back. This is the one that I said you should set it properly. Okay? So in this case, I'm throwing apples and oranges. They're all different things. So as you see, there's a function over here that throws double up there. That throw is not happening inside a try statement. But the function is called inside try statement. That's how bad it is. So when you are walking through it, you come to the throw inside this double, it suddenly jumps over here. Out of, like, there's no logic behind it. Execution just goes to a catch statement. So it's very bizarre. And you have to treat it as such. You should not use this in the logic of programming. You follow what I'm saying, right? Your business logic, you should not contain exception handling. Your business logic should be inside a try statement, and horrible stuff that might happen should go in catch, where you want to shut down everything safely. Are we clear on this? Okay, So when this happens, it starts from here. I is 0. It goes to throw double. It goes over there. The double is thrown as soon as it's double because it's in the try statement, it jumps to double. And this gets executed. Comes down, goes back up. Number 2, it comes over here. 1, a constant character pointer. A character pointer is thrown. And then it comes over here. A constant character pointer is the closest match. This is going to get picked up. And it comes back on the third one. It comes, an integer is thrown. I am not catching any integers. So 3 dots means anything that comes through, catch it. You catch it and you're done. Okay? So that's syntax of exception handling. Walk through it to show you how it walks through. This is what happens. So it comes over here. Well, this is NBB, not NAA. So it comes over here, and I say, and it comes a throwable, and it throws 2.34. It's a double, right? As soon as it throws, it comes over here, and DE over here becomes the double that it actually thrown. So what you throw is caught in here, and you can do whatever you want to do with it. And then we come up. This time it comes over here and throws a string. So now a string is thrown. And at the end, it comes, throws I. And as you see, this line will never happen because I have a throw behind it. It's impossible for it to happen. Are we okay? That's the syntax of exception handling. So we might give you a question, something like this, or in a test or whatever quiz that we have. I might tell you, like, when something like this happens, this exception is thrown. You don't need to write a try statement for that. It means you're supposed to throw an exception. Whoever's using your functionality, your class, is supposed to use that in a try statement. If any exception that is thrown that is not in the catch, the operating system is going to catch it with a message unhandled exception, segmentation fault, yada yada, code dump, and things like that. And now, let's do this. Now we have all these different types of functionalities, and let's take a look at them. Seriously? So now I'm designing a class called int, a validated integer. What it does, it has a value that it's supposed to receive. It has a validation, as you see, as a function, a string for a message. It has a get that receives gets a string from iStream, and it has a put that receives an integer from iStream, or puts an integer on the iStream, right? When I say integer, I mean this one. This sucks because the validation can only be one method, and that's what I'm using, so it can only validate in one way. I'm not going to walk through it. We know what it is. It just has one method in here, and that method is doing the validation, whatever it's supposed to be. Now, in this case, it's supposed to be invalid mark. So how do we fix this? As you see, I have different solutions for it because there are different implementations. All right. Now we're going to do the exact same thing, but this time, instead of adding a method, I'm adding a variable to it, an attribute. That attribute is mValid, which is a pointer to a function that receives an integer and a string. You've seen that. We've done it with the integer pointer. So now the validation over here, the integer gets instantiated using a value and the validation logic, and life is beautiful is after that. So this is the C version of doing this. Not C version, pointer to function version of it. Now I can actually create an integer. So this is my integer and sets the value to value, validation to validation, whatever it is, and then applies the validation in the get function. So whatever the validation is, it's going to go through it and do the validation. Okay? So it's going to say while not done and see out yada, yada, yada. And done over here is checking the validation. You see that? So it says done false. Then if validation exists or validation, if validation doesn't exist or the validation actually returns valid, done where with true comes out. If the done is not true, lazy evaluation, message is printed. No if statement done. Okay? So that's much faster, by the way, than if statement. Next. You have one of those GIFs to give to me so I can send it to? Okay. Functors. How do we write this using functors? So with functors, you have two different things. I have a class called validate. The class ends at 124? 25? Yes. Okay. So please read this for the next day. Remember, the next day you're coming, we're going to finish this and more. And next week, today, online. Have a beautiful day, everyone.